We're going to start with the paper that says where to begin and end. Okay, and we're going to be reviewing domain and range and looking at in behavior, and then also introducing you to increasing and decreasing intervals. Okay, so the first one on number 1, I'm just going to kind of talk you through number 1 and number 2, and we'll look at number 3 as well. So it looks something like this. And you have some lines over here. So let's talk about the domain first. Okay. I taught you the difficult domain. When we started looking at domain and range, I taught you like from difficult to easy. Does that make sense? We started with all of the hard domain and range. Okay. With all that has the exceptions and things like that. Today's domain and range, I think you're going to find really easy. Okay. So domain goes which direction? They are our x's and they go from left to right. So how far to the left does this guy go? Forever. How far to the right? So what would the domain be? All real numbers. Okay, all real numbers. Okay, how about range? Range goes up and down. So how far down does this guy go? Forever. How far up? So what's the range? All real numbers. Now, it's not always going to be all real numbers today, okay, but that particular one, it's all real numbers for both the domain and the range, okay. Then you have an increasing interval. So here's the idea, and you're more than welcome if you have highlighters, or if you'd like to get some colored pencils, you can. You may want to just use one color, and that's fine. You may not want to use any color. You may want to use two colors. One for increasing and one for decreasing. Okay, so listen carefully. You may want to get two colors. One, as you increase, you'll draw, you'll trace your function where it's increasing, and as it's decreasing, you'll trace it where it's decreasing. Now, here is how we look at increasing. In America, we read from left to right. So here's what I'm going to tell you. This is where everybody gets confused. Everybody, when I say increasing, they think how high. So they think what variable? They think the y. How tall am I? How far up on the graph am I? And when I say decrease, they think how low am I at? Because that's what increasing and decreasing is. But that's not what they're looking at. They're looking at the x's. So what they're wanting to know, I want you to kind of just follow with me here. Okay? As I start at the left side of this function, as I move to the right, where is it increasing? And as I start at the left, where I move to the right, where is it decreasing? And here's the thing. If the function is going up, it's increasing. And if it's going down, it's decreasing. I totally went to Walmart this morning and tried to find these little miniature little cars. You might know what I'm talking about. They're little plastic, little miniature cars. Because I always think, okay, we're going to get in our car on the left side, and we're going to travel, if the car goes up the hill, we're increasing. And I was going to have you like trace your little car up the hill. And then if it goes down the hill, it's decreasing, but I couldn't find them. So we'll use colored pencils instead. So here's the thing. It's all about the x though. So as I start at the left side of my graph, okay, I want to know where I am from here to here on my x. Yes, this arrow is pointing down, okay? But I don't care that it's going, the y is going down to negative infinity. I care that I am on the left side of the graph. So where am I traveling from? This arrow's coming from negative infinity. Does everybody understand? On the left side of the graph, my x is coming from negative infinity. And as I get in the car and buckle my seatbelt, I'm going to go, I know I'm cheesy, up the hill. And where am I traveling to? Positive infinity. Okay, now would I say that's increasing or decreasing? Increasing. So this is how you write it, the notation. The interval, x is going to be, I am increasing all the way in between. X is going to be greater than or equal to negative infinity. So it's in between negative infinity, but X is less than positive infinity. All the way between negative infinity to positive infinity, we are increasing. Okay, the function is moving up. Okay, is it decreasing? No, so you would write none. There are no decreasing intervals. Okay, it's increasing because it's going up. No, because you read it from what direction to what direction. So as I start from the left, I'm moving up. So you have to read it from left to right. Okay? And then there is a spot for your end behavior. So remind me, this will be a good review for us today. How do I write the end behavior? As x goes to positive infinity, y goes to positive infinity. As I go to the right, the y is going up. And then as x goes to negative infinity, as I go to the left, y is going to negative infinity. Any questions on that? Okay, so let's look at number 2. Number 2 looks something like this. And let's look at domain first. Domain goes left to right. So how far left? How far left for domain? How far left? To negative infinity. How far right? Forever. So what's the domain? All real numbers. Okay? How about the range? How far up does this go? Forever. How far down? To negative 3. Now, if it has a stopping point, you've got to make a statement to the stopping point. So we would say the range is all y's such that y is greater than or equal to negative 3. Okay? Any questions on range? All right, so let's get into increasing and decreasing. Okay? And here's where you might use your colors. So start at the left side. Okay? Start at the left side. As I read this from left to right. So start at the left. Now, I'm over here on the left side. So my question is, what's happening? Am I increasing or decreasing in the beginning? Decreasing. I am decreasing all the way down to this point right here. Okay, the question is, so this is going to go on my decreasing line because that's where I'm decreasing from. The question is what's the interval? I am decreasing from, now I know that this arrow is going up to positive infinity on the y, but I told you I don't care about the y. I'm talking about as I read it from left to right. So because I am on the left side, where am I coming from? Negative infinity. I'm on the left side of the graph. That is negative infinity on the x. Okay, thumbs up if you understand that. All right, so I'm coming from negative infinity is less than or equal to x, which is less than or equal to, where do I stop decreasing? You got to be very careful. I hear 0, I hear negative 3. Do I care how far down I am? I do agree I'm down to negative 3, but I'm talking about from here to here on the x. That's what I'm wanting, okay? So where is it? Where am I decreasing? I'm decreasing from negative infinity all the way to, where's this? 0. Does that make sense? It's not about, this is where people get confused because they think decreasing, it's like they think how far down you're going. They think y, but it's not the y's. It's as I read from left to right. I am decreasing from negative infinity to the left all the way till I get to 0 on the x-axis. So that's where you would be decreasing from. Okay? Then in my other color, at 0, right here on the x-axis at 0, I then begin to do what? Increase, go up. So how would I write my statement for increasing? 0 is less than or equal to x, which is less than or equal to positive infinity, because I'm going all the way to the right forever. Yes, you'll always write it, as long as you write it from least to greatest. It's saying this, that x, the interval, is everything that is greater than 0. So do you agree I'm on the right side of 0? Greater than 0, but I am less than positive infinity, because positive infinity is forever that way. So it's everything in between those two. Okay? So as long as you write it from least to greatest, it'll always be less than. Okay? How about in behavior for this one? As x goes to positive infinity, so as I go to the right, what happens to y? Y goes to positive infinity. As x goes to negative infinity, y goes to positive infinity. Any questions on that? So here's what I would like for you to do. Okay, I'm going to pause the recording, and I want you to attempt in your small group, I want you to talk about it, and I want you to, use your colored pencils. I want to see if you can do number 3. Okay, I want to see if you can do number 3. Let's look at number 3. Let's first start with domain and range. Okay, what do we think the domain is? I agree. It's all real numbers. Forever left, forever right. It is all real numbers. Okay? How about the range? How far up? How far down? Infinity. Negative infinity. So all real numbers. How many were able to get the domain and the range? Good. Okay. So let's go increasing and decreasing. Okay? Let's start at the left side. And again, guys, I only want numbers that belong on this line, on the x. As I start at the left, which would be right here, that's where I'm starting from, but I'm coming from the left. I'm decreasing from where to where? Negative infinity all the way down. Now, I'm going to tell you right now, I do not care that you are down -8. I only want numbers that are along this line. And if our differing, this one was kind of hard to read, but to me, where we decreased all the way from negative infinity all the way to where? You could have said 1, you could have said 2. I think it's more like 1.5. Okay, but that's just my opinion. Okay, if you, depending on how you were reading the graph. So I would say we are decreasing, and that's going to need to go on the decreasing line from negative infinity is less than or equal to x, which is less than or equal to 1.5. Or you could have said 3/2. You do not have to worry about the y's. Forget about the y's. It's how you read it from left to right. Now, where do I increase? So I'm going to do my increase in pink. I'm going to, at this point in time, down here, I'm going to take a turn. And I'm now going to drive up the hill. It makes me feel like I'm driving in Patrick County. Because we go up a hill and down a hill and up a hill and down a hill, right? All over the place. It wouldn't be like this. Can you imagine what this is like for people who live in like flat places? They wouldn't understand, right? But we should get this because we live in the mountains. So here we go. At this point in time, right here at 1.5, I'm now going to increase. until I get to where? 4. And again, I only want to know, so I want to state this little interval right here. So I'm going to increase from 1.5, which is less than or equal to x, which is less than or equal to 4. Okay? All right. Then I'm going to go back to red, because at 4, what happens? I start going back down the hill. Okay? And I know that it's going down to negative infinity on the y, but just as Nate said, I don't care about the y. Where am I? If I was going to state this on an interval, this would be from 4 to where? To positive infinity. So, and that's an increasing interval, right? Or no, excuse me, decreasing. So I'm going to go from 4, which is less than or equal to x, which is less than or equal to positive infinity. So those would be my 2 decreasing intervals. Okay? Because down means the y coordinate. To the right, does that make sense? I'm traveling to the right means the x is positive infinity. Okay? So again, I don't know if it will help you to draw lines on your x-axis and say, okay, from here to here, I am decreasing. And then from here to here, I'm increasing. And then from here to here, I'm decreasing. So again, like if I drew this out on the x-axis, I could say, okay, from here to here, so this is from negative infinity on the left, all the way to 1.5, I'm decreasing. And then from here to here, so from 1.5 to 4, I am increasing. And then from 4 all the way to the far right, which would be positive infinity. Okay, it's along the x. Okay, it's as you read it from left to right. Okay, as you read it from left to right. How about the end behavior for this? As x goes to infinity, as I go to the right, y goes to negative infinity. Okay? As x goes to negative infinity, as I go to the left, y goes to positive infinity. Okay? All right, see what you can do with number 4. See what you can do with number 4. All right, let's see if we can talk through this one really quickly. Okay? Domain. How far right? How far right forever? How far left? To 2. So you got to make a statement to where you're stopping at. You got to make a statement to the 2. Okay? So all x such that x is greater than or equal to 2. Okay? How about the range? How far up? Very good. It goes forever up. There is a stopping point. How far down does this go? He goes to 0. So you have to make a statement to that stopping point. So you would say all y such that y is greater than or equal to 0. Okay? Increasing. So start at the far left. Now my question is, are we starting at negative infinity this time? No, this guy starts right here. And we'll pick up with this when we get back from lunch. Okay, so if we come back, we've talked about domain and range. We're going to talk about increasing. Now, I asked before lunch, I said, are we starting at negative infinity? No, we are starting right here at where on the x-axis? 2. So what would and are we increasing or decreasing from here? We are increasing. So what would my statement say for increasing? 2 is less than or equal to, which is less than or equal to infinity. Okay? Is it decreasing? No. So you would write none. Okay? How about the end behavior? As x goes to infinity, y goes to infinity. As we go to the right, we're going up. Now this one is a little bit tricky. And I'll be honest with you, doesn't mean this paper did come from the state of Virginia. So they might ask for something like this. But I don't think, I feel like it would be something not as tricky as this. So x is not going to negative infinity, okay? I would say, if it were me, as x goes to, what's the far left point? As x goes to 2, what is the y going to? 0. That's the way I would put it. As x goes to 2, y goes to 0. But again, I don't think you'll see anything that tricky. Most of all, it'll either say as x goes to infinity, y goes to either positive or negative infinity or something like that. Okay? So what I would like for you to do is I would like for you to go to the back. Okay? And I'm going to give you time to work on the back side of this. Okay? Okay, to work on the back side of this. If you are listening to the recording, we are going to work the rest of this page, and then we are going to work the domain and range page that comes next, where you have to graph and continue to find the domain and range and the increasing and decreasing intervals and the end behavior. So it should be the same, just in a different format. And then we are going to look at the domain and range matching activity before we prepare for our test tomorrow. Okay.